calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey everybody, it is Mark Antonio here with SkyTour Radio here on KGRIRadio.com. Yay! And I'm here with, of course, Amanda Curran. Hiya, Amanda, what's up?
Not much, you?
Oh, all kinds of crazy things, but you know what? We'll keep moving forward, and we also have lurking in the background our ever-present astronomer buddy of ours, Daryl Mason. Hey, Daryl.
Hi, Mark. Hi, Amanda.
Yes.
Hi, Daryl.
And of course, as Daryl will often say, everything is better with Amanda, and I know you and the audience agree with that. And then I think that's fantastic. What's that?
And his payments keep coming.
Yes, that's right. As if. So, we want to welcome you here, and you're the amazing KGRA family of listeners that tunes into us every week. You guys are phenomenal. You guys are amazing, all of you. And we are in a little bit of flux. We've changed our time from 8 to 10 on Sunday nights to 6 to 8. And what that does is, you see, that gives us time to stream later. So it's really, the benefits are that it gives us the evening, whereas 8 to 10 did not. After 10 p.m., I would often think about streaming, but man, I just didn't get out. I didn't want to, or some of the things I wanted to see were missing already or gone. So now, from 6 to 8, that gives us a better opportunity to catch some things in the night sky, because we usually go into SkyTour Livestream when it's clear. Right now, we're not, only because SkyTour Livestream East is down until we build a new facility for it here, and SkyTour Livestream West is now, all the equipment is out in Arizona right now in storage. And I do want to thank Marianne Robb out there for literally going through hoops for us and getting SkyTour Livestream West up and running. And I also want to continue to thank Tara Diulis, who has the most amazing artistic talent, and she created the beautiful Great Nebula in Orion door for going into the observatory. And if you haven't seen it, you should go check out the SkyTour Livestream Facebook page and see what she did for the door.
Has anyone won that contest yet?
Not yet.
Contest going. Why don't you remind them about it?
Okay, then that means I'll have to give away what it was, but that's fine. You're right. I should. Tara decided that she was going to do something unique and special, and I wanted to have our logo for STLS, SkyTour Livestream, and she thought, I just let her give her full reign. Said, whatever you come up with will be fantastic. And boy, that was an understatement. What she came up with was phenomenal. She literally built the Orion Nebula on the door and the logo for SkyTour Livestream out of bottle caps, used bottle caps. Okay. And many of them were different types of drinks, but she didn't change the colors on any of the bottle caps. She's been collecting them for many years, probably 10 years or more.
Yeah, right.
Hey, Daryl.
I wonder how long it took to drink all those beers.
Yeah. No, okay. There's a bunch of Bud Lights in there because they're blue, but let me tell you, she certainly didn't drink all those for sure.
Uh-huh.
Yeah. I'm not kidding. She's really good about that. She's an artist. She has to have a clear mind. She can't do anything like that. So, all these bottle caps make this beautiful stylized Orion Nebula, Great Nebula in Orion, and the logo. And she didn't change the colors at all. She just put them together in such a way that the colors were natural. Okay, and the job was fantastic. So I do want to thank her. I can't give her enough credit, to be honest with you, because it's really quite an artistic piece. In the same way, our theme song by our wonderful Rebecca. Okay, she has created that beautiful song, "The Universe is Calling," and we use it as our theme song for Sky Tour Radio. And so you see, it's a community thing. You know, you think about Sky Tour live stream, Sky Tour Radio. Okay, well, it's only as good as the people that flock to it and decide to come, contribute to it. So Rebecca Renfro's song has been our amazing theme song. Tara's Door is the Sky Tour live stream door in the observatory. Marianne Robb's work has been literally instrumental in getting the observatory out there at all. And then, of course, we have the people whose land this is on, who are dear friends of mine. And to this point, they wish to remain anonymous, and that's fair, okay? Because, if you had all this equipment sitting on your land, I don't think you'd want to be attracting a crowd. So it's all, it's like a community thing. And very, very quickly, Sky Tour Radio became other than just me, and Sky Tour Livestream became other than just me. And I don't ever want to forget, and I will never forget all the people that are involved that made it what it is. And so it is to them that this show is dedicated. We have a lot of, and that's an ongoing dedication, by the way. So I think that this is a fitting tribute to be able to do a show like we're going to do tonight on Sky Tour Radio on kgraradio.com. And of course, Bill Skywatcher, our esteemed producer, is the reason I'm on KGRA, just so you know. I can't forget to give him credit, and I would never, because it's through his effort and cajoling me to do a show. And then, of course, Race Hobbs and Warren, the folks at KGRA, saying that it's a great idea. That's the only reason that we're here, So, it's like a machine. Everything we do in life is like a machine. We're never working alone. Okay, one piston does not an engine make. You always need to have other complementary parts, no matter how small. Your car won't work without a thermostat. Okay, not for long, right? So there's all kinds of things that are going on in the background that, and just saying this only because I want to remind everybody that when you do something in your life, remember that it's upon the shoulders of giants that you stood to get where you are. And that fact is something that has never eluded me. I'm an astronomer because I stood on the shoulders of giants before me. And so I have an observatory because I stood on the shoulders of other giants who encouraged me and helped me. So, these are the kinds of things I think that are important in our life. And with 2020 behind us and 2021, zipping along here, we're 17 days in. It's probably a fitting reminder that we just remember all those people that got us to where we are today, from our parents to our grandparents to people you've never met but who influenced you. As I've told you many stories about those that have influenced me, and I'm sure Daryl has stories like that, and Amanda has stories like that. And I'm not asking you to come up with those on the spot, guys, just so you know. But if you do want to talk about them at some point, feel free. I don't have any problem with that, because this is sort of like a good forum for that on the radio show.
Zoom, zoom.
Zoom, zoom. Yep. So, if you want to see or listen to more than just astronomy on the radio, you can watch it on our live stream, which is Sky Tour Livestream on YouTube. It's a clear night journey into the wonders of the deep sky, courtesy of research-grade telescopes. And we have one here in northwestern Connecticut, and we now have one down in southern Arizona, western Arizona, in the Sonoran Desert. The observatory's done, and I will be going out there hopefully next month. I keep saying that. It's like the James Webb Telescope, right? Next year, next month, next year. And when I finally get there, I will be installing everything, and I won't leave until we go live. It's going to be fantastic. And Daryl said I'm a traitor because I'm going to use Starlink, but that's true. I'm going to use Starlink because that gives us the bandwidth we need, and I'll just work around the satellites in the sky. That's all.
The term I used was turncoat, please.
Yeah, but you meant traitor.
Well, Maybe you should do some advertising for him. He'll fund your observatory.
I would love to get a foundation to fund me, because they wouldn't be funding just me. They'd be funding the entire movement of doing public outreach astronomy remotely. And that's what we do. That's what we do. You know, SkyTour Livestream is fantastic. You know, I came up with a bunch of these images that we did last year, sort of like the best of, and they're on the Facebook page, SkyTour Livestream Facebook page. And I changed their resolution and up-resed all of them. And some of them have been printed out by a number of people. And, 20 by 30 in size, inches. And they just look beautiful. Really, really beautiful. So I will be doing a lot of that moving forward to make sure that these are available if people want them. Just good stuff. And if anyone's interested in reading more about the stuff that astronomers do, you can get the book, The Populated Universe. It's available in 3 formats for 3 different budgets on Amazon. The Populated Universe is a story of exoplanets and how we find them, and how life might be expected to arise in the universe. It's sort of a interesting view of how the universe may be populated by life itself. There's so many paths that it takes to get to intelligence, so we may not necessarily see intelligence elsewhere. I mean, it's hard to believe there's intelligence here sometimes, but, that's also true. But for the most part, we do seem to muddle through, even for our faults. And we've possibly gotten through a really difficult age of the nuclear age. Still too early to tell. There's still some countries that want to play with that, and they could be problematic. But so the Populated Universe discusses a lot of that stuff, but it actually stays on the fun side of astronomy. And usually, what happens is in the book you'll find there are analogies that are given that make things much more clear. And it's those analogies where I really like to live, because I think that, as I've said many times before, and you've heard it, astronomy is for everyone. Science is for everyone. It just has to be reachable. And the only reason you can't reach science sometimes is because of the syntax, the language, the words. You don't know some of these concepts, and that's fair. I don't know how to do macrame, and if someone talked to me about macrame, I would have no clue what they're talking about. But if it was explained, well, I still wouldn't want to do macrame. That's not my thing. But I would understand better how it works. So if you're really interested, you can get The Populated Universe on Amazon. And there will be an audiobook soon. And the audiobook is being created by another KGRA radio host for us of the Populated Universe. And that would be Carol Carl, whose show Behind the Obsidian Curtain is every Friday night at 7 p.m., I believe. And Amanda would know that because you help her out, right?
Yeah, 7 p.m. Eastern, and she should be going to YouTube and Facebook very soon. So check out KGRA DB for digital broadcasting on YouTube and Facebook, and check her out. Lots of other great shows too.
We're going to be going there too at some point, I believe.
That's the plan.
Yeah. So,
Mark, can I ask a question?
Please do.
Were you a scout?
For what?
A Boy Scout, Cub Scout, whatever.
Yeah.
You ever get into tying knots? Are you good at it?
I got into some knot tying. I'm not good at it anymore, no.
Okay. Well, that's really all you need to know for macrame.
Wait, See that?
I did a little macrame way back in the 70s.
Daryl asked.
Daryl's a jack of all trades. What can't he do?
I know, that's kind of interesting. Yeah, well, that's really funny.
Knot tying is not my forte. I'm left-handed. I always had a hard time reading those knot tying diagrams in the manual.
Mm-hmm.
I think Mark's left-handed too. Yeah,
I am.
I think our producer Bill is left-handed too.
Oh,
well,
only left-handers are in their right mind.
Yeah, exactly. I was going to say that. Yeah, exactly. So, and only left-handed people are in their right mind, right? If they say, and it's too bad that analogy really is kind of obsolete, because they discovered that left and right-brained people there really is no left and right brain. It's just different parts of the brain are active, but it's all over the brain, but just different places that are active when you're doing a left brain traditional task or a right brain traditional task, like creativity versus mathematics. Okay. All the brain is active, but it's just in different areas. So it's like, I was a letdown because I thought, hey, I'm a lefty, you know, I'm in the right mind, you know, but nah, joke falls flat now, especially with people who know, you know. So that's too bad. But hey, you know, it's okay. Now you might say, well, enough of the silly talk, Mark. What are we gonna do tonight? Well, I haven't figured out what our show's gonna be tonight. I kind of have a script, a little bit. No, actually, I do. But you know, I want to keep it open for discussion too. So if Daryl or Amanda want to talk about anything, or even if Bill wants to jump on in and say some things, and he's probably shaking his head, no, right now. But hey, too bad, Bill. You know, we like having you on. But I think we'll start with something that's actually really interesting. You're familiar with the TESS satellite that I've talked about before. TESS stands for Transiting Exoplanet Survey Satellite. You know, we saw TESS launch, and it was beautiful. And TESS has a different approach than Kepler. The Kepler's space telescope, if you recall, would look at an individual star, and it had 100,000 or so of these stars it was looking at over its lifetime. But it would look at one star and look at the light and measure the light for a period of time to get what's called a light curve to see if there's something passing in front of the star dimming it. That something would be a planet. Well, TESS is doing the same thing. However, TESS is doing it with hundreds of stars, if not more, every moment, because TESS's field of view is not like a laser beam type view like Kepler. It's actually a gigantic 25 degree by 90 degree plus field of view. And it's looking at all those stars at once. And it's finding quite a lot of interesting things out there. And one of the things it found is this guy we have on the Exoplanet Roundup, which you haven't heard about in a while. And this is a planet that it found around the star called TOI 561. Well, TOI stands for TESS Object of Interest, just like KOI was Kepler Object of Interest. And this is 561. So clearly there's a lot of TESS objects of interest out there. And this particular planet is called 561b, little b, like we do the nomenclature for planets around other stars. And it saw this transit, and when it figured it out and looked at everything, it realized that the star it's coming from is a star that is incredibly old. Not only that, it turns out that the planet itself is almost as old as the universe itself. Now, this is important. We've talked about this before, and we'll bring it up at the end of this. But you know, the universe is 13.8 billion years old, if our Hubble constant is correct. Now, don't worry about that. That's something for another one, and we've talked about it before. But let's assume 13.8 billion years old. This planet is 10 billion years old. That means that it's really, really a planet that was around shortly after the beginning of the universe itself. That's a very important fact, and it's not the first time we've seen this. But the fact that it's 10 billion years old shows us that the universe has had an ongoing sliding window of planetary formation. Now, this particular planet is really, really close to its star. It only takes half a day to go around the star. Okay, so 12 hours. And it's a super Earth, meaning it's 50% larger than the Earth, but it's also 3 times as massive. And it's the mass that we care about in terms of being able to calculate its orbit. Being a little bit larger also makes it a little more visible to us when it's doing a transit in front of the star. So, but being 3 times more massive, it means that its gravitational pull or force is 3 times more than it is here. All right. So that will give us clues as to its orbit, and that was used to calculate a lot of parameters. But it is very close to the star. It's so close, in fact, that the temperature on its forever day side, because it's tidally locked, is 2,000 Kelvin on the day side, and that's 3,140 degrees Fahrenheit, right? And on the night side, it's going to be similar if there's an atmosphere, because the atmosphere on the hot side would tend to circulate around the planet in cyclonic, powerful winds. If there's no atmosphere, well, then the nighttime side might be cooler. So that's unknown as at this point. But the star that it formed around, this TOI 561, aren't these romantic names? It's amazing. Call it Bob or Sally or something. I mean, but the star that it belongs to is in this very rare population of stars called the Galactic Thick Disk. And that means that it's a star that doesn't have a lot of heavy elements in it, like iron and magnesium. But wait, iron and magnesium make up planets. So how can this planet be there at all? That's part of the mystery, you see. And there are other planets like this out there. And being one of the oldest, it gives us a lot of clues as to how the universe was undertaking planetary formation, in those early years. Now, there is another planet that's older still, and that's we've talked about this, and Daryl, I think you know this one too, the Methuselah planet. Familiar with that?
Go ahead.
Yeah,
We'll see if I remember.
Well, it was PSR. This is the attractive name for it. PSR 2320-26b, little b.
Why didn't I remember that?
I know, right? Well, but the Methuselah planet is actually almost, and this is the part you might remember, it looks like it's nearly 13 billion years old. So if the universe is ostensibly only 13.8 billion years old, it means that planetary formation was being done right after the universe began.
Is it a gas giant planet? I mean, for stars so old, I would think they are the, what are they, population 2 stars, population 1, whichever ones were the first generation of stars after the supposed Big Bang,
yes.
Before so-called metal elements showed up.
Yeah. Well, these planets, these, if you remember, and what Daryl's alluding to, guys, is the fact that, stars make the heavier elements in our periodic table. And when stars make things like iron and so forth in their cores, they get released back to the interstellar medium when that star goes supernova. So it takes a lot of those cycles to populate the interstellar medium with all this new material from which new planet building and star formation can occur from. And that is what he's talking about. And in that time where there were early stars being made, there had not been a lot of supernovae. There had not been a lot of mixing in the interstellar medium of this material from supernovas that may have existed back then. So where does the material come from? It comes from hydrogen and helium that's made in these stars. And when we say they're metal poor stars, what it means is they don't have anything other than hydrogen and helium in their atmospheres. There's some things in there, okay, but primarily hydrogen and helium, which are the primordial elements, those made up the first stars because there were no heavier elements yet. So the fact that these planets exist, the fact that the Methuselah planet exists out there, means that it is very likely, as Daryl pointed out, a gas giant and not rocky, because rocky would mean that there'd be magnesium, there'd be iron, nickel, and other elements other than hydrogen and helium. And that may not be true. A gas giant, on the other hand, wouldn't be subject to that. It might have a rocky core, but that rocky core could just be ultra-condensed hydrogen that's so dense that it actually becomes something that it's conductive. It'll conduct electricity, basically. And that's like Jupiter might have a metallic, it's called, hydrogen core. So these old planets, likely gas giants, but still, if you think about it, That's old for a planet to exist, right? It's really old. And the Tess planet, the reason that one is pretty special is because this may be a rocky planet in a part of the universe and made it a time in the universe when rocky didn't exist. Okay? So it's an interesting story. We're going to continue to follow the odyssey of Tess Object of Interest 561. That's the star. And then 561b. Really cool stuff, I'll tell you, Now,
did I hear you correctly that basically the planet's year is 12 hours long?
That's correct.
Yeah.
Yeah.
Okay, just wanted to make that clear.
Yeah, it goes around the star in half a day. So for every day here, the planet goes around the star.
Half an Earth day.
Yes.
Because 12 hours is a full day, so they don't go around in half a day.
24 hours is a full day.
On Earth.
Yes. So for every day on Earth that transpires, that planet goes around its sun twice. 12 and 12. Okay.
Anyway, well, I think that had to be one hot heck of a place. Hellish, if I may use the word.
You may. It is.
It's sort of like a hot Jupiter, whatever they call it, but smaller.
Yeah.
I think it'd be pretty toasty there.
It is, in fact. It's 3,000 degrees Fahrenheit on the day side. And, of course, it's probably tidally locked, too, because it's so close to the star. Tidal locking is a phenomenon that occurs like with the moon. The moon is tidally locked to the Earth, where we see the same side of the moon as it goes around. It rotates once on its axis every time it goes around the Earth. And overall, that keeps the same side facing us. We're robbed of the far side of the moon, guys. That stinks. So planets that are tidally locked will do the same thing. It was thought originally that Mercury was tidally locked to the sun, but it turned out that our now defunct and lost Arecibo radio telescope is the telescope that discovered it is not tidally locked in the same way. Its year was it 59 days? Do you remember, Daryl? 59 days, or because we say it goes around the sun in 88 days, which is true, but it also revolves on its axis, I think, once in 59 days, less than that amount of time.
I don't recall offhand.
Okay, well, no worries. But either way, you see, we're unraveling some mysteries of the universe little by little. It's taking us some time, but we're going to get there, darn it all. Now, the next thing that I wanted to talk about with you guys was something else, which I think is pretty cool. You might have seen... Huh?
But we'll have to talk about that on the other side of the break. I know. Cliffhanger. We do it to you every time, but stick around. Stick around and hear more.
All right. We'll be right back, as Amanda says right after these words.
I'm getting older and noticing that my body just doesn't work as well as it used to. So I like to keep fit as possible by hitting the gym a few times a week. Recently, I started having a nagging bicep pain, and it got so bad I couldn't even lift the weights. When I was complaining about it to a friend, he told me about Angioprim. He said chelation helps remove toxins, heavy metals, and cholesterol in veins and arteries that may cause blockages. After just 1 week of taking Angioprim, the pain was gone, and now I'm back in the gym full strength. Scientific research proves the active ingredient in Angioprim has superior oral chelation action that helps promote cardiovascular health. So to learn more, go to angioprim.com. That's ANGIOPRIM.com, or talk to a trained consultant. Call Angioprim toll free at 945-882-7221. You'll feel better with more energy. That's 945-882-7221. Or go to the website angioprim.com.
Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied, but you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to ancientlifeoil.com. That's ancientlifeoil.com. and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Permanent industrial glue impossible to remove? Not anymore, because Handyman Formula by D-Bond is a patented chemical adhesive remover. It's used in the building and home maintenance industry, but now it's available for your home use, for your DIY projects. Unglue stickers, silicone rubber, labels, price tags, flex tape, weather stripping, carpet glue, wood glue, liquid nails, even 3M 5200. And it dissolves graffiti. Yeah, graffiti. Handyman Formula by D-Bond works, and it's safe to use on most surfaces. No need to call a professional. Don't get out the pliers and blowtorch. Just apply a little Handyman Formula by D-Bond and wait 90 seconds, then quickly and easily pull the items apart. Get unstuck. Visit DBondHandymanFormula.com. That's DBondHandymanFormula.com or call 561-575-4200. Handyman Formula by D-Bond.
Mainstream media's most wanted. KGRARadio.com.
Hey, welcome back to Sky Tour Radio. It is I, Mark D'Antonio, the guy that doesn't know my own timing here. I get so into these things that I forget we have to take a break. I don't know, I'd rather just do astronomy, it seems. But you know what? We do have to make room for sponsors, So before the break, we were talking about the test object of interest, that planet, the Methuselah planet as well. And now we're going to move down a different path. And that is, we're going to talk about a story that was brought to us by our own Amanda. Dun, dun, dun. Little flourish with horns and so forth right there. Just hear that in your mind, Amanda. And it has to do with something called the leap second. Things with time always bothered me in astronomy. I never wanted to learn about the time stuff because it's like, oh, come on, just put me in a telescope. I want to look at the telescope. I want to look at the sky. I want to figure out what that thing is, But worrying about earthly time issues just seemed like so silly. But over time, I realized that it's actually the crux, the core of what we learn in astronomy, and I'll give you a reason why. Now let's first look at. We're going to talk about the leap second, but let's first look at what's happened to the Earth over time. Since its formation, the Earth was formed, and then of course we were hit by something approximately the size of Mars in the latest theory, and we had a ring of debris basically around the Earth for quite some time. Much of that debris rained back down on the Earth. It rained down on the object that was coalescing out of all of it in the orbit around the Earth. And it finally ended up forming just outside what's called the Roche Lobe. That's R-O-C-H-E, the Roche Lobe. That is a location within which a cohesive planet / moon could not exist, right? It would be torn apart by the gravity of the Earth. Well, it was outside that, all right? And that's sort of like an automatic thing that'll happen. It'll automatically, you get to that point where it'll only form outside the limit. It won't form inside the limit, then be destroyed typically. So that said, the moon formed, all right? And so when the Earth formed and just after the moon formed, okay, the daytime, the day length on the Earth was only 4 hours long. Can you imagine that? 4 hours long, an entire day. So squeezing 24 hours down into 4, okay, that's 6 times smaller, so that's a 6 times shorter day. And that's when the Earth and Moon just formed. Now, when life arose on the Earth, that was around 3.5 billion years ago. If certain people say, well, maybe 3.8, whatever. Let's just use 3.5 billion years ago. Life arose on the Earth. By then, the day was 12 hours long. What's going on there? And then when we had plants that formed that could take sunlight and convert it into food, basically, that was around 2.5 billion years ago. And by then, the day was 18 hours long. And when complex cellular life, what we call eukaryotes or eukaryotic life, arose, the day was 21 hours long. Now, why was that? Why was the Earth slowing down? I know.
I know.
I'm getting to you. I know, because that's fine. I think it's great. I was sort of a cue by going silent. I was waiting, thinking, Daryl, are you gonna say something? I know. Yeah, he does. He does know. He's actually quite good at this too. So we have to consider that we do have oceans here on the planet now. Okay, and Daryl, I want to hear what you have to say as well. So go right ahead and take it and run with it if you like, and I'll fill in any blanks or add more blanks.
Conservation of angular momentum.
Define that.
Tidal effects of the moon generating tides in Earth's oceans have slowed down the Earth's rotational rate, and that's also causing the moon to move slowly farther away in its orbit around Earth.
That's right. And the reason that happens, I mean, if you think about it, why would something that doesn't even contact anything, like the moon doesn't contact the Earth, so why in the world would the moon move farther away from the Earth? What is causing that? Well, if you think about it, we have tidal bulges, right? Now, if we look down on top, there is no up or down, but let's pick one and say down on top of the Earth, it's going counterclockwise. As the Earth's rotating counterclockwise, the friction of the land masses against the ocean is dragging the ocean along with it. But the moon is tugging on those bulges, and those bulges try to come up just under the moon, between the Earth and the moon. But because of the friction, they're actually dragged a little further forward. And so the highest point of the bulge is literally a little off the Earth-Moon axis. And that literally adds a tiny, tiny, tiny velocity component to the moon's orbital speed based on the tiny, tiny, tiny amount of additional gravitational force that the moon is feeling. So the center of gravity of the Earth is not quite where the center of the Earth is, as seen from the moon. The result is the moon it's picking up a tiny little bit of speed every second, every moment. And I'm talking minuscule amounts of speed. However, over the course of a year, that amount relates to about 3.8 centimeters per year. All right, when it all adds up. So that is the reason why the moon is moving away. And it's also that friction and that tidal pull on the bulge of the oceans is the reason that the Earth is slowing down. Now, if we didn't have oceans, would the moon still be moving away? That's the question. It's a trick question. And the answer is, I'll just give it to you. Yeah, it probably would, but less so. But the reason is because the gravitational pull of the moon would not be deforming an ocean body, but would be deforming the land itself. Okay? And so that would cause changes, because as the Earth rotated, the land would try to rise and then subside, try to rise and subside, and that would cause a similar type of force on the planet as well. And don't forget, we have the sun at the other end. It's also pulling on the Earth. So we have double duty here. And the sun's influence is much further away, but the tidal force from the sun is half of that of the moon. So we're talking about a substantial amount of tidal force energy. So yeah, that's exactly what it is, as Daryl said. And now that's why the Earth has been slowing down. And that same process that leads to the moon going further away, as Daryl mentioned, as I mentioned, over time as the Earth is rotating and slowing down, it turned out that every year to a year and a half, we had to add a parameter called the leap second to the length of our day every year. And this is because every single day, all right, our day increases by the Earth slowing down. Our day would increase by about 0.002 seconds. All right, so over a 1 to 1.5 year time span, this adds up to about a second. But in actual practice, the actual time that was added is less than a second. Usually between 0.4 and 0.6 seconds would be added. All right. And it's been a regular process. There's some guy in a room somewhere with a little hat on, a little visor that's transparent, probably green. And he's looking down at the screen going, yep, okay, we're approaching, okay, okay, we're going to add a leap second right now. Click, boom, leap second added. I mean, it's a little more complicated than that, but you get the idea. So this has been a regular process, like I said, and the leap second would usually be added like on June 30th or December 31st. In the middle of the night when no one was awake, so no one would know what would happen. However, there's been a bit of a change. It seems that Earth was also in a hurry to get rid of 2020 because Earth rotated faster this past year and no leap second parameter was added to our official day. In fact, we won't be seeing a leap second added later in 2021 either. Earth sped up. Now, why would Earth speed up? Now, we know the familiar case where you have an ice skater on the ice, arms extended, and as they start to spin, as they pull their arms in, they go faster and faster and faster. Does that analogy apply here? Maybe, but in a very loose sense. We've had some concerns with our weather. The weather has been changing. There's been El Niños, all right? And it's possible that maybe with solar activity, interactions with the atmosphere, or a lack of solar activity, when there was expected solar activity, it's possible that the atmosphere shrunk a little bit and didn't expand as expected, and that could possibly have caused the Earth to kind of speed up in the millisecond range. We're talking about milliseconds, not like minutes. So that's something interesting that I really think is worthy of study, right? To figure out what processes might have caused the Earth to speed up. Now, maybe it was something in the core. Maybe there could have been some large-scale magmatic movement in the core that caused the Earth to speed up, but it would have to be something that we would have noticed. We would have seen it. So the most people can say is it was probably due to weather changes. Maybe tectonic activity, but our angular momentum was offered perhaps or altered perhaps by something like an El Nino or solar cycle quiescence, which means like lack of. So it's possible, but just know that 2020 was the year that Earth also wanted to forget. It's pretty interesting. I don't know if you want to add anything else, Daryl, but feel free.
Well, all I'll say is the people who decided to do that are in France, okay, which says a lot to me. But I always thought time was administered at Greenwich, the Greenwich Observatory in England, or the UK. But it turns out that, just like the people who administer the metric system, the people who administer time also are in France, and leave it to the French. This goes back. This is a subject for another time. Goes back to the whole problem I had with the metric system. I mean, the original definition of the metric system was the meter was 1/10,000,000th of the distance from the Earth's equator to the North Pole, but that was along the line of longitude that passes through a suburb of Paris, France, where this observatory was. Yeah. And that's a very specific number, and that's a very Earth-centric number. That's a very French-centric, Paris-centric number, and nowadays they have all sorts of fancy definitions for the meter. I forget. It was something with the element krypton, or now I think it's like how long a wavelength of a certain laser light goes in a second or something of the sort. But ultimately, it boils back to it was 1/10 millionth of the distance from the equator to the North Pole as measured along the line of longitude through Paris, France. And the Earth's not a perfect sphere, so that number really, I think, has no more validity. But there, I just said what I wasn't going to say.
No, that's fine. Okay, I get it. I mean, I think the modern take on the meter is it goes more to the length of the path traveled by light in a vacuum at like 1/299 millionth of a second, something like that.
Yeah.
Which is kind of strange.
Well, that's, it's they factored the speed of light and divided it by how many kilometers there are in a light second and divided it by that number. And so, hey, that's what a definition of a meter is now.
Yeah, I mean,
but, what are the roots of it? It goes back to along that line of longitude.
Yeah, they backed into that definition, when using light. They just said, hey, let's define it in terms of light.
Sure.
Okay. Okay. How far does light go? How long does it take light to go a meter? Well, it takes 1/299,792,458 of a second.
Yeah. Well, if you look at the historical precedents for all this, England, the UK, they declared Greenwich, England, to be where the zero line of longitude is for purposes of chronometer use, which originally dated back to accuracy of timekeeping for shipping purposes, for determining their latitude and longitude on the Earth, for accurate shipping, and so they didn't crash into rocks and stuff. I always figured the French were jealous of that, so they based the length of the meter running through Paris, France, just to get back at the English.
Well, it all depends too on the.
This is history in action, folks.
Yeah, it all depends on the historical and cultural relations at the time that these definitions were originally made.
Exactly.
So
for people to say, well, the metric system is scientific, this is a contrarian in me. I really, it's no more scientific than an inch being the length of the first knuckle on King John's thumb or whatever it is,
Yeah. Because what if King John was actually born a giant? Well, then everything would be way smaller than we think it is, right?
Yeah.
So anyway, yeah, that's pretty cool.
Sorry.
No, look, these discussions, I think, are the kinds of things that people like to hear,
I like hearing it. I think that's interesting. Whether it's true or not, that's very interesting. It could be. Makes sense.
Are you saying Daryl's not telling us the truth?
Well, I'll just keep my comments to myself. But no, and I like how things are measured. Like a foot should be like a foot, but it's an approximation. So for accuracy, they have to come up with something, I guess. But Charles actually had a question.
Okay.
He wanted to know if the melting polar ice sheets would slow the rotation.
Well, that's a good question. The melting polar ice sheets would, in fact, affect the rotation of the Earth. And the reason is because there'd be more volume of water to make up that tidal bulge. All right. And more volume of water indicates that we'd see more friction. The Earth would be slowed down a little bit more. Would we notice it? I don't know that it would be noticeable even if the entire ice sheet, that's both poles, melted away. I don't think we would notice it without long-term analysis. Then we could say the most important thing to see, because we know that the slowing is occurring, right? Just not last year. But we notice that the slowing is occurring, and we would know to be able to calculate a rate of slowing. And if that rate increases, so last year it was this amount of slowing, and this year it's a little bit faster rate of slowing, so it's getting slower faster. Okay, if you can figure that out, then maybe. And Charles, I think that you always think out of the box, and I think this is an example of where you are as well. You would find that a higher volume of water could conceivably contribute to slowing down because of the fact that the tidal bulges would be more voluminous and have more water in them, more friction. And so, yes, I would think that they would.
What if space-time itself and relativity, the curvature of space and the strength of the gravitational field, if that changed, that would certainly change our perception of time, would it not?
Well, I think that if that all changed, our perception of time is the least of our concerns.
Well, just a tiny change. I'm sorry. I guess it just occurred to me that this is something we may talk about after a while.
I think this might be a good topic for one of our discussions, Daryl. I think so, because then we can actually, prepare some really good analogies for folks to be able to follow this. That's a really good idea. See, folks, that's why Daryl earns his money.
Buddy?
Exactly. What'd you say?
Hey, if I win the Powerball or the Mega Millions, it's so big now. Maybe I'll buy you a big telescope for your desert observatory.
Oh man, I won't hold you to it, but boy, would that be great. That would be great. Amanda, do you have any other questions for us while we're talking about big observatories and telescopes?
No, we had a question from earlier when you were talking about the gas giant.
Oh, yeah, okay.
Another one from Charles, and a wonderful question. He wants to know how the gas giant atmosphere, how could a gas giant's atmosphere not have been stripped in time scale? More questions about time.
Yeah, it's possible that it is being stripped. Here's one of the things that happens, Charles. When we look at a large planet, we look at a planet that's really near a star, we have to say to ourselves, that planet may not have always been there, okay? The planet may have actually transported there, not via transporters or through some sci-fi stuff, but, transported from further out, spiraled in. Maybe it's possible that the orbit wasn't ever entirely stable. Maybe there was a destabilizing force in the solar system. The star itself could have been this cause, and thus caused the planetary system to actually, or cause that planet to actually slow down enough so that it would then take up an orbit slightly closer to the star and closer. This could have taken hundreds of millions or billions of years to occur. And it depends on the conditions. We see the finished position. It's really close to its star. And if it's a gas giant, then if it still has its gases, one of the things we can do is we can look at that atmosphere and study it over time and see if the atmosphere is in fact being leached off of the planet. We have seen planets that literally have what we would call tails. And they are tails of atmosphere that have been literally vaporized off of the surface of the planet, off of the atmosphere of the planet, rather. And as the planet goes around in its orbit, it leaves this ring of material behind. And so we can see that. And so it's possible that it does happen. And so that makes sense to me in terms of when we see planets. But I always look at things as these are a snapshot in time. We're not looking at it where it formed, most likely. We're looking at it at its final or near final position. It may have been a lot further out. Should our sun turn into a red giant, and it will someday, then maybe the stellar material that gets thrown off of the star will cause the Earth's orbital speed to slow somewhat. And thus, over time, we can actually find ourselves spiraling into our sun. And you can imagine that, say, 7 billion years from now, it might be a civilization out there, kind of where we are today, and looks at our planet and say, oh, look, there's a planet really close to its star. Wow, that's pretty cool. How did that happen? Well, how that could have happened was that it spiraled to the star, spiraled into the star. Not every planet does this. Some planets do take up residence really close to their stars, right from the very beginning. But the fact is, we don't know for sure where this planet came from. We don't know the chronology, the order of events that occurred in this system yet. But isn't it fantastic? It is just the most amazing thing ever to be able to be party to this. And the test team is certainly very interested in it too. And we would like to know more about this planet for sure. Now I know we may very well have more questions coming in, but I do want to keep everybody on the loop here that we will be coming up to a break here in less than a minute. But I will take. I do want to just mention really quick that when we actually go live in Arizona with Sky Tour West, I hope that all of you and then some will attend. It's going to be a banner event, I can tell you that, because I'm thinking we might even do a formal dedication of the observatory out there during the late afternoon and then go live that night. And I'll be there for that. And I would love to see other people there too. I do know, and I'm going to tell you now that I've confirmed it, the other group that's going to be joining us in the observatory with a telescope and doing their own independent work will be P&K Space Imaging, Paul and Keith. They are going to put a telescope in on pier number 2. Pier number 1, of course, will be our pier for Sky Tour Livestream. And so there'll be a pier number 3, and that'll be up for grabs. Anyway, we'll be right back after these words, but stick with us here on KGRA Radio with Sky Tour Radio and Daryl and Amanda.
Please listen. Now is not the time to fear. When your immune system is strong, shields up. You have very little worries. If your immune system is compromised, you're susceptible to all viruses. I say shields up and no fear. Try Heart Love from GetTheTea.com. Heart Love has a special ingredient called allicin. It comes from the healing part of the garlic plant. No garlic breath, no garlic leaking out your pores, just pure immune-building ingredients that gets your shields up. Heart Love is a unique blend of herbs that loves to build you up. Google garlic and know the benefits. 1 Heart Love pill is equal to 20 cloves of garlic. 20 cloves! Shields up. You've heard of our Life Change Cleansing Tea at GetTheTea.com. Now try Heart Love. And by the way, take your blood pressure and watch weekly what happens. So here's how to purchase. Log on to GetTheTea.com. That's GetTheTea.com and build your shields. That's GetTheTea.com. Mention Ray in the coupon code and hit apply and receive free shipping.
When you're in the house for longer periods of time, you can see them flying or running across the floor. Ooh, yuck. They're unhealthy, gross, and disgusting. Bugs. I loathe bugs. We keep a clean home, but occasionally bugs show up. Well, I found something that is tougher than bugs. Orange Guard. On contact, it kills hidden bugs, including ants, roaches, and fleas. Plus, Orange Guard is a residual repellent. All of the ingredients of Orange Guard are on the FDA generally recognized as safe list. Orange Guard may be used around food, humans, and pets. It comes with a 30-day money-back guarantee. Orange Guard. Available at orangeguard.com, Whole Foods, and Ace Hardware.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, the KGRADB.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Now you have the inside contact for alternative talk radio. The Planet. KGRARadio.com.
Hey, welcome back. This is SkyTour Radio, in case you're wondering. We are now on from 6 to 8 p.m. Eastern Time on Sunday nights. And as I said before, and I'll say again, that time affords us some, a much better opportunity to stream after we do our radio show. And so going from 6 to 8 has turned out to be a much better solution for us than going from 8 to 10 in the evening. That's my story, and I'm sticking to it. So, that said, when we actually start streaming, now I'm in Connecticut right now, but when I go to Arizona, I will be in that time zone. But we're going to probably stream, from probably like 11:30, 12 o'clock midnight Eastern Time onward, because that's when it'll be dark in Arizona. So
Mountain time zone is best time zone.
Well, that's true, and the fact that Phoenix doesn't change its time shows that it's in Mountain time for part of its year, and it's on Pacific time for the other part of its year. So if you want to call it that way, if you want to pigeonhole it into, I guess, having a time zone, right?
Yeah.
No, it's okay. I don't mind.
I'm not a fan of daylight savings time anyway, so set it on standard time and leave it there year round.
I always thought that would work as well, and I never saw a reason why. Is it only because people didn't want to go to work in the dark? Well, they do anyway, depending on what time of year they're in. So I don't know. It's always been a strange conundrum. Why?
It's funny you guys are against that, because like you would think astronomers would be all for it because it's trying to be as accurate as possible, isn't it?
No, it's a convention is all it is. And as far as astronomers go, all that means with daylight saving time is you have to wait another hour before it gets dark.
On the clock.
Yep.
Yeah, on the clock, yeah.
Yeah. Huh. So, yeah. So, I think that makes a lot of sense, and one of the things that, if you want something that doesn't make sense, our next story that you brought this one up to me, Daryl. It has to do with one of the latest potential findings. I call it a potential find because it's not guaranteed that it actually does reflect what's really going on, but it looks like it's possible. And it has to do with those gravitational waves we've talked about before. And if we look at the fact that when black holes collide, we see the residual impact by the gravitational waves that propagate away from the event in the same way, a similar way, that a puddle will send out concentric rings when you drop a pebble into it. Well, those are waves as well. And water is acting like a wave in a wave nature at that point. All right. Now, if you stuck your head underwater, when the pebble went into the water, you'd hear bloop, you'd hear it in your ears. And then the waves would follow after. So not all phenomena come in at the same time. So it's pretty cool. And when we talk about gravitational waves, what we talk about with this particular finding is that it looks like there's a gravitational wave background in the universe. Now, and that I, if I recall, that is something actually, Daryl, that you had sent this story. So I wanted to kind of give you the opportunity to discuss it, and we can have a discussion about it if you like. It's your call.
If he comes off mute.
If he comes off mute, maybe, yeah.
We can have a great discussion.
Sorry, I was sending something that Amanda had asked for. Amanda, I just sent you a link if you wanted to post it.
Perfect, thank you.
To this article.
So people in Discord will have a link to what you guys are discussing now if you want to follow along and look into it. Thank you.
Yeah, it's the gravitational background.
Yeah, I have it in front of me here. Okay, I don't profess to be an expert on any of this. I just happened to read this the other day and thought Mark might find it interesting.
And apparently he did.
Oh, golly, hang on. I'm getting messages at very inopportune times. There it is. There you go,
Sorry,
Amanda.
That's my fault. Thank you.
This is a general purpose article or a general science article, Universe Today, linking to a scientific paper, which is at the bottom of the article. If you follow the link, Amanda's going to post, I think. And the scientific article made absolutely zero sense to me. It was over my head. That some scientists are looking nowadays at what they are calling a gravitational wave background to the universe. And what I found interesting about this, it sounded analogous to like the microwave background in the universe. You know, the echo of the Big Bang.
That's right.
When the Big Bang went off, I mean, it was infinitely dense and infinitely hot and therefore infinitely bright at the time. And what is left of the Big Bang nowadays has due to frequency shifts, is way down in the microwave. It's a few degrees of absolute zero, but we still can hear, so to speak, an echo of the Big Bang. Mm-hmm. And now it sounds like somebody's trying to draw a gravitational equivalent to the the gravitational background in the universe. But as I understand it, they hear or they detect gravitational waves in space, not just from mergers of black holes and or neutron stars, etc., that the LIGO instrument and the Virgo instrument in Italy, made the big landmark discoveries a couple of 3 years ago, but that they think they are detecting gravitational waves as a general thing, say from single black holes, which, they're not interacting, but they are still disturbing the gravitational smooth background of space, I guess you would say.
That's a good
one. It's interesting to contemplate. What I was thinking in all this is we're seeing this in other areas of astronomy now, that it's like a multispectral imaging, combining different aspects of astronomy, everything from the radio and infrared through visual up through ultraviolet and even X-ray and maybe gamma rays. You've probably seen images by now where they took, say, a Hubble image of a certain deep sky object like a galaxy, and they are superimposing other frequencies, other wavelengths on top of that they have gotten from the Chandra X-ray Observatory, for instance, or the Spitzer or some other infrared observatory. And so now you're seeing compound images where they have combined several disciplines of astronomy into single images that are hopefully showing more of what's going on out there in our universe. And I guess this would carry on in a gravitational sense, that they could somehow fold this in with the cosmic microwave background. I'm probably reaching here a lot from what the article originally said, but it's just what kind of rang my bell about this and made me send it to Mark in the first place. And if you want to jump in, Mark, feel free.
No, I'm enjoying this because I think that your take on this is actually quite prescient. You've got it as far as I can see, and as Daryl, as you said, they're looking at basically a hum in the universe, right. Gravitational waves. And the cosmic microwave background, what we call the CMB, is also now going to be joined potentially by the gravitational, the the gravitational background, right? So that's another possibility. But one of the things I want to just go through first before talking about that potential background is why it's a big deal. And I don't think the articles clearly point out enough about that. But basically, it comes down to this, and this is something that, Daryl, I think you know anyway. But if we talk about gravitational waves, okay, Einstein predicted them, okay, but he also predicted we might never see them. And there's a reason for that, which we'll get to. But gravity and their potential wave effects would actually be very hard to see. Now, to understand why, let's look at in physics, the four fundamental forces, right? Otherwise known as the fundamental interaction that anything has with anything else, okay? There is a gravitational force, electromagnetic. There's a strong force, known by that name, strong, and a weak force. Now, gravitational was probably the first one ever found, and that was the one that Isaac Newton made clear and put some science around. All right. And then the electromagnetic force was discovered. Now, James Clerk Maxwell in the 1800s came up with this. And this is the force that we talk about when we look at like positive charges that repel each other and negative charges that repel each other, but a positive and negative charge attract to each other. Okay. All right. That is the electromagnetic force. And then we have the strong force. Now, what does strong pertain to? It actually pertains to atomic nuclei. There's lots and lots of energy bound up in these atoms. Just look at what happens when we force them to undergo fission, where we split nuclei apart. Okay, this force acts between those smaller particles that make up the protons and the neutrons in an atomic nucleus. All right, and those particles are known as the quarks. Okay, and that's what the strong force pertains to. Now, we know protons have a +1 charge and another proton with a +1 charge. Together, those will repel each other, right? So why do they stay in an atomic nucleus? It's because the strong force overwhelms that repulsion, that natural repulsion, all right? And the last force we have is one that's called the weak force. And the weak force is responsible for various types of radioactive decay. But it's odd, okay? If we look at the weakest of all forces, it's actually not one you might think, right? And you might not think it's weak at all. But if we rate the fundamental forces in order of strongest to weakest, the strongest force equals the strong nuclear force, all right? Next is the electromagnetic force. And then, believe it or not, the weak force is next in terms of strength. And finally, dragging up the rear is the gravitational force. Gravity, the force that holds Pluto to the sun billions of miles from it, is actually the weakest force there is. It's extremely weak. And listen to this. If you wanted to build a particular detector to detect gravitational waves coming from a certain mass object that wasn't in the order of black holes, the detector alone would have to be so massive that it itself would become a black hole. It would collapse on itself and become a black hole. So gravity is a funny duck, as we say. Now, mass of an object will determine its gravity. It takes an object, though, the size of our sun, which is 860,000 miles across, and a mass of 333,000 Earths to keep a hold on the planets. Okay? If you compare that to how a tiny proton in an atom can maintain an electron cloud, which at its particular distance from the proton is a huge amount relative to their sizes, you'd see that would relate to something way bigger than our solar system, and it's still maintaining and keeping that electron. So that's why gravity is the weakest force. All right, now if you want to look at the recent findings to see that illustrated, let's, as Daryl just said, let's look at the recent findings, okay? We see that there's a whole background of gravitational waves in the universe. And like the cosmic microwave background, the CMB, we have the gravitational wave background, potentially the GWB. Now, this implies that if gravitational waves are moving throughout the universe every which way, that if they were very strong, or were ever very strong, then any star system with planets that ever formed, okay, would be torn apart by these errant gravitational waves coursing through the universe. But they haven't. When they come through our solar system and they're detected by, as Daryl pointed out, the Laser Interferometry Gravitational Wave Observatory, LIGO, okay, and Virgo, a similar counterpart in Italy, when they're detected by those detectors, they come and go. Do they affect us? No. So interesting, isn't it? So that's exactly, that exactly points out the difficulty of detecting gravity or ever even doing something like reflect it to get anti-gravity. Daryl, you're going to say something. I'm sorry.
No worries. Well, I feel a Star Trek moment coming on. There was one episode where this young guy, he was kind of hippie looking, and he had chin whiskers and a mustache. He was flying around in a thing that looked a whole lot like a small flying saucer with a clear, clear transparent dome on top of it. And Starfleet sent out an emergency message because, oh my God, there's something creating huge gravitational waves, and it's shaking the entire galaxy, the entire universe, and it turned out that was this guy's shenanigans. There were actually two of him. One was rational and one was crazy, and they had some trouble figuring out which one was which. Do you remember that episode? I'd have to look that up.
Was it the original Star Trek?
Yeah, the original series.
So the one with Shatner?
Yes.
I don't remember. I could use a primer here.
I would have to see if I could find it. Give me a few minutes, maybe.
This is where they were like white on one side, black on the other.
Oh, no, that was the one with Frank Gorshin. This guy, he was rather handsome. He was kind of tall, kind of skinny. He had chin whiskers and a mustache. And
was the episode called Lazarus?
Yes, I think that's it, Lazarus.
That's right.
Thank you, Kathy. They're on it. Our chat is good.
All righty. Way to go, Kathy. Yeah. But his carrying on was shaking the entire universe, and oh my God, we had to find this guy and stop him.
I remember that.
Yeah. What I wonder with all this, though, they have been wrestling for a long time with the so-called unified field theory or the theory of everything, and the problem has always seemed to be folding gravity in with the other basic forces that we experience, and maybe this would be an avenue to fold them all together ultimately.
Yeah, maybe. I mean, the question is gravity quantum? Do we have quantum gravity? And that's been a question for the ages.
Sure.
And I think that's
maybe this will open that window, just like I was talking about the multispectral imaging of deep sky objects, that we may learn something very deep and basic behind all this.
Yeah. If you think about it, I mean, we can't even travel to the nearest star systems, never mind the outer planets, in a couple of hours. I mean, that kind of process could happen, and you know what? All of this stuff that we're talking about really makes me think that we should actually do a fun feature here tonight. What do you say we go into the science of Star Trek?
That's what I get for opening my big mouth, I guess. Yep.
That's exactly what you get.
Yeah.
Science of Star Trek. Now, many of Gene Roddenberry's famous show concepts have been created or appear to be able to be created. There's, we talk about it. We see it often. Science fiction becomes science fact. And this stuff does happen, and it catches up to us and we don't even realize it. All right. And, when the writers began writing the science scripts for Star Trek, they began with what was known for science at the time. And then they extrapolated where it could go. And then they made that the new science, right? Well, in some cases, they hit it right on the money. They got it exactly where it should have been, right? And then on the other side, they basically kind of missed the boat, and we kind of outdistanced them, even almost as the show went to air. But still, the human race has been pretty clever, you know. And one of the things, for instance, that I thought was really clever is if we look at some of the simple devices on Star Trek, the communicator, right? So, you know, Kirk would call up to Scotty, you know, Scotty, you've got to beam me up. And Scotty'd say, "I said, I'll do my best," right? Well, he'd flip it. It was like a flip phone, right? And it was basically Scotty who would get it, you know, and answer it and say, "Scotty, yeah." And, you know, Kirk would tell him, "Scotty, got to get my ship out of there," you know. But this actually appeared decades earlier. All right, this concept appeared decades earlier in a comic, all right, that featured an intrepid detective with very cool gadgets. Do you remember who he was, Daryl?
Dick Tracy.
I do.
Yeah. Did we even say that, Amanda?
Yeah.
Yeah, Dick Tracy. Yeah. That's right. He had something called a two-way wrist TV, and every time you'd see a comic, you'd see the wrist, and then there'd be a little arrow pointing with little words, two-way wrist TV. Well, that's just FaceTime on an Apple Watch now, by any other name, isn't it? Right?
There you go.
Yeah. And the current smartphone is far better than the Star Trek era communicators, which is the equivalent of that limited flip phone walkie-talkie, for crying out loud. You know, Kirk would throw it away and buy an iPhone or a Samsung Galaxy, more likely, you know. And the devices are really incredible. And you know what? They can even make phone calls. I know. Hard to believe. They can even make phone calls. You know,
would this make the Star Trek Next Generation era communicators, you know, the little badges they wore on their uniforms, would that be more equivalent to like a Bluetooth, for instance?
Perhaps with a central hub, right? But it would work off planet. Now, the other thing too to keep in mind is that these communication devices, like when you click the badge, you hear that little squawk thing. That right there is sort of old school. Why should you have to touch it? Well, Siri on the iPhone, you can just say, "Hey Siri," and Siri will answer for you. Okay.
Yeah. Well, this was the 1980s and 1990s, you know.
Yeah, that's right. But the thing is, okay, it's just the beginning too, because like there's another device that they had come up with, all right, which I thought was pretty cool at the time, right? And it was called the Universal Translator. Do you remember that? The Universal Translator?
Yep, I remember.
Yeah.
Hey, I saw a translator back in 1990. I was attending a factory school in Germany, and there were people there literally from all over the world attending this school. It was how to work on this certain company's large format printing presses. And some guy, I forget if he was from Japan or Taiwan, he carried a translator with him. It didn't work very well, but hey, there you go.
Well,
I was trying to teach him how to bowl, of all things, and
that's funny.
Trying to, you know, translate the word "smooth," if I remember right. You know, when you roll the ball, he never did quite get it, but he may just have been uncoordinated.
Oh, well, I'll tell you. Okay, nowadays,
you know, it's like wax on, wax off, that sort of thing.
Mm-hmm. Mm-hmm. Well, we have the equivalent of universal translators now, essentially, for Earth languages. And like, for instance, if I say, "Hello, my name is Mark D'Antonio, and this is Sky Tour Radio." Well, I don't speak Italian, but I can just hit a button now and say this.
Ciao, mi chiamo Mark D'Antonio e questa è Sky Tour Radio.
Okay? And that's just...
Ciao, mi chiamo Mark.
Oh, yeah, sorry, yeah, okay. I mean...
Can't get him to shut up either, can you?
I know, right? But then check this out, okay? Now, I only speak a little Japanese, not much, but this is that same sentence Hello, my name is Mark D'Antonio, and this is SkyTour Radio in Japanese.
こんにちは。私の名前はマーク・ダントニオです。これはスカイツアーラジオです。
Now, a little rough, but basically it was Konnichiwa, watashi wa Mark D'Antonio, that's kore wa SkyTour Radio desu, okay? So, and then this is kore wa, this is SkyTour Radio. So, now, for someone who doesn't know Japanese, then this is a godsend, right? A universal translator kind of thing. And I think it's hilarious. It's fun, okay? So universal translators do exist. And I won't play the same thing in Albanian or Russian or Filipino, but I mean, it's there. You know, it's there. Really cool. Now, interestingly, there are other science creations that are underway that aren't quite there yet. And we'll talk about those, too, when we come back. But there's at least 5 or 6 more of these that we have to touch upon. And so we will talk about those when we come back on SkyTour Radio. This is Marco D'Antonio on SkyTour Radio. And I'm here with Daryl and Amanda, or Amanda and Daryl. So you do both ways, so nobody can get mad at me. We'll be right.
Bar Clum the Fartar. See if you can translate that.
A birthday without her mom. An anniversary without her husband. Her wedding day without her dad. These are the days when military families feel it most of all. The loss of their soldier, their sailor, their airman, their Marine, their Coast Guardsman. Families never forget their loved ones lost to war or illness or suicide. Families never forget, and neither do we. We are TAPS, the Tragedy Assistance Program for Survivors. We provide resources, support, and comfort to heal the hearts and meet the needs of grieving military families, all at no cost to them. Your generosity can make an enormous difference in the lives of the families of our fallen military heroes. Our military families need to know they are not alone and they are not forgotten. Show them your support at TAPS.org.
Is that who I think it is?
Yep, sure is. Did you hear he ditched the man cave and brought back the study?
That's so sexy. I love it when a man is educated and informed.
He is so dreamy, always reading books and investigating history.
Where do you think he works out?
The library.
He is so controversial, always talking about 9/11 being an inside job, the police state, constitutional rights, ancient history, government cover-ups, and how he thinks sports don't matter in real life.
Oh, I love a freethinker who searches for truth. I love it when he feeds my brain. What's his name? Kristan T. Harris.
Tune in to The Rundown Live with Kristan T. Harris, Monday through Friday, 12 to 3 p.m. Eastern on KGRADB.com.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey, welcome back to SkyTurf Radio. This is Mark D'Antonio with Amanda Curran and, of course, Daryl Mason. And we are talking about the technology of Star Trek. And I promise you another one that was really cool. And that next one is the cloaking device. If you remember, the Romulans famously had a cloaking device which made their Romulan bird of prey, the Romulan bird of prey would vanish just before Kirk would fire on them. Captain Kirk would fire on them.
Klingons
really, all
had
they
them too.
Huh?
Klingons had them too.
That's true. And all Kirk had to do was just listen for when the music would change. Because when the music changed, that's when they were going invisible. And he'd have an edge on it, but he just didn't listen to the music.
Uhura once said that thing still has to have a tailpipe, don't it?
That's right.
That was Star Trek VI, The Undiscovered Country.
Mm-hmm. Yeah. So I think that would be kind of funny, But, cloaking has been, throughout science fiction and fantasy, right? I mean, Harry Potter had the what was that? The cloaking cloak. What do they call that? Amanda, do you know by any chance?
I do not know Harry Potter. I'm sorry.
Okay, it was like
surprising. You think I would, but I don't.
Sorry. There was a cloak that they threw over themselves, and they would become invisible. But one more commonly known is the Predator franchise, and that featured one as well, where the Predator actually, in that case, it was more actually scientifically plausible, where the creature was utilizing everything around him and behind him, and shunting it toward the front and sending that out. Maybe his garments, maybe his body had these specialized systems built in that can actually render the background on the face and on his outfit, and this would make him essentially invisible. All right, and why would the Predator alien do that? Well, I mean, it makes perfect sense. Arnold Schwarzenegger pointed it out clearly when the alien decloaked. He goes, "You are one ugly beep."
J.R.R. Tolkien
here. What's that?
I'm sorry, J.R.R. Tolkien sort of had a cloaking ability too in Lord of the Rings. He wrote that back in the 40s, I guess.
Okay.
You mean when he put the ring on?
No, well, that too, but no, when they visited the Elvish Queen Galadriel and the forest, whatever it was called, one of her parting gifts to the members of the Fellowship of the Ring were Elvish cloaks, and if you put the cloak on, it sort of cloaked you. You kind of faded into the background. You looked like rocks.
Huh. Well, cool. I mean, that technology, not quite there yet, but we do have some of that technology. And again, in an interesting science fiction becomes science fact, there's a military technology currently being developed that will take a fabric garment that you're wearing and use whatever the background is behind you to place it on that fabric. All right, it'll work out a way. It'll be looking behind you, and it will put the fabric or the background onto your front. I watched the guy walk. He had this special shirt on. He walks in front of a brick wall, and as he walks in front of the brick wall, he becomes a head walking in front of a wall.
What if they have hoodies? You'd just be like hovering faces all over the streets.
Exactly.
That'd be freaky.
Yeah. However, it is really very, very advanced technology. So that kind of fabric probably isn't very comfortable to wear, number one. It probably has a lot of sensors in it, number two. And it's probably got to be hooked up to a computer, number three, that's not just battery powered in your pocket. There's probably a dozen cables that are attached from the back of the garment back to a computer so that you can actually get this to happen. That's the first phase. Don't forget, the first computer occupied a very, very large number of rooms. Okay? And now it is effectively your iPhone, your cell phone, and of course the PCs of various kinds and sizes, right? So I think it's pretty cool, and so this cloaking technology, again, not quite there yet, but it's still there. Still there, right? Don't forget the size of the first microwave. Actually, don't forget how microwaves were discovered either. Do you know the story, Daryl?
I've heard it. I don't recall it offhand.
Yeah.
My first microwave was a great big old thing. I know that.
Yeah, it was, right? Yeah. Well, microwaves were discovered quite by accident, and that brings up another point. Many of these scientific discoveries that we're talking about, both actual and wannabes, like in the science fiction world, many of these are actually discoveries made through serendipitous means.
Absolutely.
Yeah.
Happy accidents.
Yeah, and happy accidents is another topic for another show, but we can still touch upon them. There's a number of things that we discovered, one of them being the microwaves, okay? And that led to microwave ranges, and then led to microwave ovens, and then microwaves, right? Short form. And if someone pulled out a microwave that you put on a small counter and compared it to the first microwave, they'd probably think it was science fiction. Such a small device, and that little magnetron that's causing it all in there was just an amazing device. However, it was found quite by accident because one of the people working with this large magnetron had a chocolate bar in his pocket. And after working on the magnetron, he discovered that the chocolate bar had melted into his pocket and really made a mess. Now, trying to find out the reasons for that, they discovered that the magnetron was giving off this special microwave ray, basically, as they called it. And they didn't know what it was until they studied the spectrum more, and they figured out that's where microwaves exist. And it was just an incredible invention that came about completely by accident.
Could have been worse. He could have turned into the Incredible Hulk.
Well, that's true. That wouldn't have been worse for him unless, maybe it would. I don't know. That's true. That's true. So, so I really think that, that's kind of cool. And the cloaking systems, I watched the tank driving on the battlefield, and the tank, you can see the tank itself driving along. It was a British tank. And when they activated this particular cloaking technology that the tank was using, suddenly the tank was gone, and literally gone. However, you could still see the dust it was leaving behind it. As Uhura said, like you said, it still has a tailpipe. Okay. Well, there was still dust being kicked up by the treads on the tank because it was in a dirt field. So the tank was gone, but you saw where it was, and it just had an odd look to what was in front of the trail, and that was the tank. And again, it was creating the background on these panels that were on the side of the tank. Probably a new form of cloaking to come. All right, military project. They always are. The other thing that I want to say is, you remember, the view screen on Star Trek is a big giant screen, right? And we think of them as now big screen LED TVs. Yeah, okay. But that's old school. Why go to such a primitive mechanism when you can do it so much easier? Okay, after investing all the time to make it from a so much harder concept to become an easy one. How do you do it? Well, I think it was a Japanese company that came up with a special paint that you paint the wall with. And in the simple form, the paint is electrically conductive. And depending on what current you put through the paint, depending on what current hits the walls will change color. So if you don't like your gray wall, you can turn it into a red wall or a blue wall or a fuchsia, magenta, purple, black, and that was the interesting phosphor paint project. And you guys can look that up and see it. It's pretty cool. Then there was another advance where they were taking this paint and turning it into true full-blown RGB wall elements. So you could literally, on this specially rendered wall, literally have a full wall-sized TV. That is still in its infancy. But then again, so are flexible screens. Flexible screens, you've seen them on many science fiction shows, where they fold the screen up and they put it in their pocket and they take it out, unfold it, and it's a full-size screen. That technology actually exists. You know, if you watch the movie or the TV show The Expanse, they pull out these little clear acrylic-looking squares, and these acrylic squares actually then become screens. They then they can interact with them. So in other words, they can do what you do on an iPad now, but on a transparent screen. Now, just out of curiosity, Daryl, you remember, and maybe even you, Amanda, there was a Star Trek episode, The Voyage Home, I believe it was, where they actually picked up whales. Remember that?
Oh, yeah, Star Trek 4.
Yes,
The Voyage Home.
And
Hunchbacks, sir.
That's right.
Humpback whales.
Humpback? No, he goes, humpback? People? No, Scotty. Whales, Scotty. You know? And so in order to get it to happen, they had to have these large tanks made. So Scotty and the crew go off to a special place that makes big tanks, but they wanted them to be lightweight so they could carry them on this particular spacecraft. So what they did was Scotty sat down and
I know where you're going.
Yeah, and he actually ended up having the guy who was sort of a silly guy. It's sort of like he's a character actor who always plays the dumb guy, but ends up being made into the hero kind of a thing. I don't know his name, but you know,
he was a nerd.
Yeah, and he goes. The guy looks at the screen after Scotty designs this thing really fast by just hitting keys, because that's how it works in the movie. You just hit keys and boom, you get these multi-month designs just appearing in front of you. And the guy looks at the screen and sees this chemical analysis or this molecular formula, and he goes, transparent aluminum? And so they made this transparent aluminum. Well, at the time...
As Scotty told Dr. McCoy, well, how do we know he's not the guy who invented it?
That's true, right. But the thing is, I just saw a story not 2 weeks ago that says it looks like transparent aluminum could be a reality. And it talked about this new material, aluminum type of material, that was going to be a hybrid material that would be transparent. Now, in its prototype stage, it's translucent, but not transparent. But they're heading forward to true, total transparency. Now, isn't that cool?
Yeah. It's funny you mentioned this, because I've seen things about this just in the last few days. They're pretty much doing it now with aluminum oxide, aren't they?
Yes, that's true. And what's funny about this is that if you were to consider that aircraft windows in commercial airliners are weak spots on the plane, you've heard of times when motor parts fly and hit the windows, pop them out, and people die. They get pulled out and all kinds of things go bad. Well, what if the entire structure of the aircraft could be a window, if you wanted it to, and you could determine what part of the window you wanted to be transparent, or what part of the wall you're sitting next to that you want to be transparent. Think about the change. Well, first of all, in fear of flying, because, if you saw nothing under you except the ground, that would be kind of fearful from 30,000 feet, I would imagine. But imagine the possibilities. Okay, so it's possible that we might find that transparent aluminum, especially in the thinner walls, like in aircraft walls, might make itself into the mainstream before long. It's actually an interesting concept. And aircraft windows would no longer be a problematic point, because the airplane itself would be all the structure would be all throughout the aircraft, and only at those points do you decide that this is where my window is going to be. I can see a future where the kid sitting in the window seat will just draw an ellipse on the wall, with some type of stylus or whatever, and boom, that part of the window becomes a transparent section.
Sure. Along that line, if you think back to Star Trek The Next Generation, the control panels everywhere,
yes.
There were no physical buttons. They were just like colored pictograms. And
that's right.
You'd see Data sitting there hitting these little colored blocks and making things happen. Arthur C. Clarke wrote about controls with no moving parts way back in the 1950s, I believe.
Mm-hmm.
And if you watch the old original Star Trek still, they had toggle switches and stuff like that. But by the time of The Next Generation, they had, no moving parts in their controls.
That's right.
But heck, the monitor on my computer has that, the on-off button. There is no physical button there. There's a little light down in the bottom right-hand corner that shows it's illuminated. All I have to do is touch the frame above that, and there's no physical button at all, but it turns it on and off.
Yeah, that's exactly what it is. And some of those are like by piezo, electric touch. Some of them are by other sensors, proximity sensors. There's things you don't even have to touch, and of course the proximity of your hand to them will shut them on or off, right? Yeah. Very interesting stuff. And so I think that you see, these are the future developments that were thought of so long ago, and it goes on and on into science fiction, and I'm telling you, science fiction does often become science fact. In 2001, A Space Odyssey, Keir Dullea and the other actor, I forgot his name. You remember the other actor's name in 2001?
Oh, golly, I forget. He was also in the Star Trek pilot.
Yes, that's right.
One with Sally Kellerman.
Yeah. Well, anyway.
I can't think of his name.
Me either. But, okay, if you remember, they were using things that look remarkably like iPads to do their daily diagnostic work.
Mm-hmm.
And that was a concept that, my good friend Douglas Trumbull came up with as a way by which they would interface with the computer on board. They would go through these devices he envisioned that had all these controls on them that were not touch controls, touch controls, but not physical actual controls. And they would just touch and move things around to actually do stuff. And that was the original iPad. And in some circles, Doug's credited with the creation of the concept of the iPad, because they're about the same size as the 9.7-inch iPad that's out there, the iPad Pro. And what's interesting is, I remember bringing this up with those folks, because at the studio, we actually did the iPad Pro commercial for the Super Bowl one year. And when we did that commercial, we weren't allowed to know what it was for, but we all figured it out after about 3 days. And then I mentioned, Doug, aren't you the guy that invented the iPad? And he kind of laughed, right? It's like, well, no. But, it was a concept very similar, yeah. So you see, it's sort of a great minds think alike, and science fiction does become science fact, right?
Mm-hmm. Now, and Gary Lockwood was the actor's name.
Lockwood, thank you. That's right. And he was the guy with the eyes.
On Star Trek, yeah.
Yes, he had the eyes that could, do things. And Captain, I'm very powerful, that kind of thing. We have to beam you off into space and kill you, kind of a thing. So I remember that. That's right.
Yeah, Sally Kellerman was the woman.
That's right. And she had the eyes, too.
Yep.
Very cool. Thanks, Amanda. She said Gary Lockwood as well.
That, again, was from Kathy.
Okay. Thank you, Kathy.
She's on it.
Yeah, that's it. I love it. Thank you so much.
Trekkies out there.
Yeah, well, Trekkies, Trekkies by any other name are future thinkers, really, right?
There you go.
Because we see that and look at that as our future. And who knows, they grow up to be engineers at some point, and then they think about the things they saw in their childhood and said, I want to make that,
Well, I think if it can be imagined for the most part, I think it'll eventually come to reality.
I do believe that. I think you're right.
Absolutely.
Like, for instance, another another staple in science fiction is the concept of the tractor beam, right? In Star Trek, the tractor beam would grab onto a spacecraft and pull it toward another. And these beams usually had an iron grip on the ship, and the crew could only ride it out. The Borg, for instance, would latch onto a ship and use cutting beams to disassemble the ship and assimilate the crew. Remember Captain Picard on The Next Generation? He was taken by the Borg and converted into one. Famously, he said, "I am Locutus of Borg. Resistance is futile. You shall be assimilated." Right? Well, in reality, no tractor beam exists. However, there has been research since the 1960s to the present day on both tractor and repulsor beams. And these have kind of actually been met with limited success. So, I mean, it's not, they've actually had some limited success with these. But success is the operative word here, okay? They've actually managed to create effects that would create a pull or a push force on small microscopic particles. And we're not talking magnetic forces on pieces of iron, okay? But that's as far as it's gotten to this point. But if you think about it, isn't that how everything starts with us? It starts at the microscopic level, and then we scale it up. That's what we do.
Well,
that's what we do.
That's where they're going with transporters now, or, quantum tunneling, stuff like that.
Let's talk transporters, okay? We have a few minutes left. The transporters in Star Trek would disassemble you in, up in orbit, say, and reassemble you moments later on the planet's surface via a beam that sends your atoms at the speed of light to the surface. In order to do this in Star Trek, they had to have this thing they called a pattern buffer that stores the complex relationships between your atoms and uses this as a blueprint for reassembly. Now, in a sense, that kind of sounds easy, doesn't it? But, in fact, that part really isn't that easy. The closest analog to that is very different. But it does point to some tantalizingly interesting relationships between the atoms. And one of the things that kind of brings it to light is the concept of quantum entanglement. Now, basic experiment to show that quantum entanglement occurs was to separate atoms from a material and put them in separate locations. Okay, just accept that. Now, if you cause the properties of atom 1 to change, atom 2's properties across the way on the other side of the campus or even far out in space, if you could get it there, would be the opposite, as required by quantum mechanics and their structure. So the atoms are not directly in contact, but if one atom's properties are known, then quantum entanglement says you immediately know the properties of the other atom. And in practical terms, you measure the properties of atom 1, and you do the same for atom number 2. You find that atom number 2 will have the complementary properties of the other atom every single time. Change atom number 1 and its properties, and atom number 2 will have somehow recognized this and made the complementary change on its own. This means that somehow these atoms are in communication, entangled, so to speak. So this is the kind of thing that, as we talk about, this is that spooky action at a distance, if you recall, that Einstein called it. And not just Einstein, actually. So there's many different things, right? But that's the closest thing we have. And I think that there is and I know we have to go here momentarily, but, when the phone rings and it's that friend you've been thinking about for the last 15 minutes and you haven't talked to him in 10 years, and you say, "I was just thinking of you." What do you say? What a coincidence. But is it? Or is it that quantum entanglement, but at the brainular level? Something to think about. We have done it again, folks. You've wasted another completely crazy 2 hours with us here on SkyTour Radio. Thanks for coming along. And we will talk to you again next week. This is Mark, Amanda, and Daryl signing off for now. You have a good evening. And remember, when you go out, keep looking up.
Except while you're driving.
Good night, everybody.